So you're wanting to determine the domain and the range of the function that is given, and we have to recognize first that this function is an exponential function. The basic form of an exponential function is f of x is equal to b to the x power. Now there are several things that are going on in this particular function. First, b, our base, is the number e, about 2.71828. And then we have to recognize that because there's a 1 added to the x in the exponent, this is shifting to the left 1. And because there's a minus 1 at the end of the equation, then this is shifting down 1. But we also want to recognize that the sign of the number in front of the e is negative. There's a negative 1 in front of that function. I shouldn't say in front of that function, but in front of that base. And whenever you have a number in front of your power, and your power is the base and its exponent, whenever the number in front of that base and its exponent is negative, what happens is it ends up being a reflection over the x-axis. So our exponential growth functions, and this is growth because e is a number greater than 1, it's about equal to 2.72. We have to think about the fact that our parent function for exponential growth goes through the point 0, 1, has an asymptote on the x-axis, and curves upward for growth. In our problem here, we've got a reflection over the x-axis, so now it's going to be down in quadrants 3 and 4. It's going to slide to the left 1 and down 1. So we always perform the reflection first. So if we reflect over the x-axis, it's going to look something like this. This is a tricky one, where now it goes through the point 0, negative 1 instead of 0, positive 1. But then we have to slide that down 1, or down 1, and left 1. So our asymptote slides down 1, and our point there at 0, negative 1 slides down 1 and left 1. So what's going to happen is we're going to go down 1 from that point and left 1. So now that point's going to be here. So now our graph's going to look something like this. And our asymptote has slid down 1 as well. So now it's not at, sorry, I put that in the wrong place. Now it's not at x equals 0, at y equals 0, excuse me, but rather it's at y equals negative 1. Okay? So our final graph, I'm going to erase the intermediate graph that I got when I reflected. Our final graph, I'm going to get rid of this dotted line because I put that in the wrong place. Looks like, oops, looks like this. With our asymptote down 1 place from the x-axis. So we can see with regards to domain, it's going to go forever right and left, and therefore the domain is all real numbers. I'm guessing they want interval notation, so that would be from negative infinity to positive infinity. But our range, we know it's not ever going to get up to that asymptote at y equals negative 1. So our range is going to be as low as negative infinity, because it's going to keep going down and down and down and down, but it never gets to negative 1. So negative infinity to negative 1, not including negative 1, which would result in our interval notation looking like that. So we performed the reflection over the x-axis first. Then we took our y-intercept of 0, 1, which became 0, negative 1 when we reflected, and we slid it 1 place to the left and 1 place down. We also note that the horizontal line that was at y equals 0 on the parent function has now slid down 1, so now it's at y equals -1, which helped us identify that our range goes from -infinity to -1.